So here I am presenting the PPT, that is presentation on the distributed DBMS reliability. So what's the exactly reliability is? A reliable DBMS is one that can continue to process user requests even when the underlying system is unreliable. That is, even when the failures occur in the system, wherever it is, because we are studying the distributed database. So database is distributed over a wide area. So whenever the failure occurs, still the reliability of the DBMS should be continued to preserve. So what kind of failures can be appear on in the database transactions? So the transaction failure can occur, or the system failures, that is the system crash or the power supply failure. Then the media failure, that is hard disk failures, and the communication failures, that is lost or undeliverable messages. So the reliability is closely related to the problem of how to maintain the atomicity and the durability properties of the transaction. So the recovery system should be there to preserve the reliability of the system. So the recovery system ensures atomicity and the durability of the transactions in the presence of the failures. So even though the failures occur, recovery system will recover the whole database, which will consist of the whole data, which should be consistent, and all the transactions should be atomic and the durable. So recovery algorithms have two parts. So firstly, we need to take precautions also, and we need to take actions also. So the first is the kind of a precautionary action. And so the action taken during normal transaction processing to ensure enough information exists to recover from failures. So whenever the failure occurs, we should have the recovery system which will take the actions in order to take the normal transaction processing. And the second is the actions taken after a failure to recover the DB contents to a state that ensures atomicity, consistency, and durability. So the previous state where the database was consistent throughout. So that kind of failure should be recovered. There is a local recovery management. The local recovery manager maintains the atomicity and the durability properties of local transactions at each site. The architecture consists of the volatile storage and the stable storage. Volatile storage is nothing but the RAM, and the stable storage is which never loses its contents. So in reality, this can only be approximated by a combination of the hardware and the software, where the software failures or the hardware failures may occur. So in those failures also we need to cache the stable storage. There are two ways for the LRM, that is local recovery manager, to deal with update or write operations. So first is the in-place update and second is the out-of-place update. So in-place update is having physically changes the value of the data item in the stable database. So it directly changes the stable database. So even when the in-place update is executed, then the data consisting the the data inside the stable database was the permanent database. So whenever the physical changes occur in that stable database, it will be permanent forever. So previous values will be lost. So and it is mostly used in the databases. And the out-of-place database is what? The new values of the updated data items are stored separately from the old values. So we will be having the two states of the database, which is the previous state and the present state. So whenever we will require the previous state, we can get it back. So periodically the updated values have to be integrated into the stable DB. So whenever the next kind of level will be occurred, that is next values will be coming, then the old values will be we will let it be the old values, and the new values will be accepted by the database. The distributed reliability protocols are there. Most problematic issues in the distributed transactions are commit, termination, and the recovery. So whenever we will commit some transactions, it may occur some it may create some problems, or the whenever we will terminate some connections or the terminate some transactions, then there will be some problems, and also in the recovery. So the commit protocols are there, in which we need to see how to execute a commit command for distributed transactions. And so whenever the distributed database is there, we can say that someone else is not accessing the database at the same time when we are accessing it. So whenever that person will commit particular transaction, we need to see that if it is consisting some kind of values which are being used by us. So if we are also using some values which are shared by that person, then we need to check out the consistency of that particular values or the whole database. So how to ensure atomicity and the durability, we will see in the commit protocol. There are termination protocols and the recovery protocols. Those protocols we will not see in this particular presentation. We will focus on the commit protocols. So the termination protocol is what the basic is if a failure occurs at a site, how can the other operational sites deal with it? So we need to see it. And the non-blocking state is that the occurrence of failures should not force the sites to wait until the failure is repaired to terminate the transaction. And the recovery protocols is what? When a failure occurs, how do the sites where the failures occurred deal with it? And the independent is a failed site can determine the outcome of a transaction without having to obtain remote information. So the remote information is not required by the recovery protocols. And the non-blocking state is the termination protocol, where the blocking state if occurs, then it will be deniable termination protocol. Commit protocol is having primary requirement of commit protocol is that they maintain the atomicity of distributed transactions. So atomic commitment should be there. That is, even though the execution of the distributed transaction involves multiple sites, some of which might fail while executing, the effects of the transaction on the distributed DB is all or nothing. And so it should be in a particular state rather than confusing between 2 or 3 states. In the following, we distinguish 2 roles. So the coordinator role is there and the participant role is there. Coordinator role is that the process at the site where the transaction originates and which controls the execution, that is the user. And the participants, the process at the other sites that participate in executing the transaction, that is the particular server or any other database site. So there are 2 protocols mainly, that is centralized 2-phase commit protocol and the centralized 3-phase commit protocol. Very simple protocol that ensures the atomic commitment of distributed transaction is the centralized 2-phase commit protocol. There are 2 phases, that is phase 1 is the coordinator gets the participants ready to write the results into the database, and the phase 2 is nothing but everybody writes the results into the database. That's coordinator will see what kind of persons are updating the database. So the global commit rule is that the coordinator aborts a transaction if and only if at least one participant votes to abort it, and the coordinator commits a transaction if and only if all the participants vote to commit it. So at least one participant is saying that abort it, then he should abort it, and if all the participants are saying that commit it, then he should commit it. Centralized is that since communication is only between coordinator and the participants, then there is no kind of intruders to interact with that particular communicator. So it is a centralized protocol. But problems are there with the 2PC protocol. A protocol is non-blocking if it permits a transaction to terminate at the operational sites without waiting for recovery of the failed site. So even if a site is failed, then also it should commit or else whatever, abort it. But here the non-blocking state is there. That is, it is waiting for the recovery of the failed site. So 2PC protocol is blocking. Ready implies that the participants waits for the coordinator. If coordinator fails, site is blocked until recovery, and independent recovery is not possible. So the problem is that sites might be in both, that is commit and abort phases. Then other protocol is the 3-phase commit protocol. Three-phase commit protocol is a non-blocking protocol when the failures are restricted to single-site failures. The state transition diagram contains no state which is adjacent to both a commit and an abort state, and no non-committable state which is adjacent to a commit state. So adjacent is means what? Possible to go from one status to another with a single state transition. And the committable, that is all sides have voted to commit a transaction, and the solution is there, that is insert another state between the wait and the commit states. So the conclusion is that recovery management enables resilience from certain types of failures and ensures atomicity and durability of the transactions. Then the local recovery manager enables resilience from the certain types of failures locally. LRM might employ out of place and in place strategies to deal with updates. In case of the in place strategy, an additional log is used for recovery, and the distributed reliability protocol are more complicated, in particular the commit termination and the recovery protocols. The 2PC protocol first gets participants ready for the transaction, that is the phase 1, and then they ask for the participant to write the transaction, that is the phase 2. But 2PC is a blocking protocol. Then the 3PC first gets participants ready for the transaction, that is the phase 1. Then pre-commits or aborts the transaction, that is phase 2. And then ask the participant to commit or abort the transaction, that is the phase 3. And so 3PC is non-blocking. So thank you.